Okay, students, now we are going to discuss about second experiment. So we are going to start the discussion with second experiment, and second program of ML lab, machine learning lab. So it is related to candidate elimination algorithm. So here it is written candidate elimination algorithm. So already we discussed finder's algorithm. So in case of finder's algorithm, the limitation of finder's algorithm is it will deal with only positive examples, right? So here what we are going to take advancement to the finder's algorithm is candidate elimination algorithm. So it is the superior algorithm than finder's algorithm. So it will deal with positive data as well negative data, positive data and negative data. So here if you look at what is candidate elimination algorithm, we are going to discuss how does it work and what are the limitations of candidate algorithm and implementation of candidate algorithm. So we are going to discuss about these topics so in this class. So one more important point is candidate algorithm deals with positive examples as well negative examples. So let's see. So here in case of candidate elimination algorithm, we are going to discuss about concept learning. So what is the concept which we are going to discuss? Concept in the sense, suppose we are going to discuss with cars. Let us assume we are discussing with cars. That means what is the model, what are the features of the car, and we discuss about this particular element in detail way. So that is the concept. So whatever the topic which we are discussing, knowing about that particular concept is concept learning. And general hypothesis, specific hypothesis. In case of finder's algorithm, we deal with only specific hypothesis. So what is a specific hypothesis? It deals with pi. It is represented with pi value. Okay. So whatever the initial value which we are going to consider for hypothesis, that represented with the help of pi. So here, and we are going to add about general hypothesis. What is general hypothesis? General hypothesis is represented with the help of symbol question mark. So most specific to most general. So generally what we are going to consider, this is the space, and if we are going to consider it is a specific hypothesis, and this will be the general hypothesis. That is a specific hypothesis, general hypothesis. So in between specific and general hypothesis, whatever the data which exists, all this data, so this is treated as version space. So whatever the data which deals between the specific hypothesis and general hypothesis, that will treated as version space. Here we are going to have three terms. One is general hypothesis, specific hypothesis, and version space. So let's look at one more details. So what is given, you can consider this as an extension of candidate elimination algorithm. What is extended? So whatever the concepts we learnt in the finder's algorithm, so for the finder's algorithm, this is the extension. And here we are going to consider both positive and negative. Already I told with you. So what we are going to consider, positive and negative. So actually positive examples are used here. Finder's algorithm, already we have used positive examples, and what we are going to have negative examples. So it is specified from generalized form. So already told you. So in case of finder's algorithm, what we have taken specific hypothesis only, and in case of candidate elimination algorithm, what we are going to have, general hypothesis. So here general hypothesis deals from negative examples. So this is about, we are going to discuss about candidate elimination algorithm, and what are the terms we are going to be used. So terms are concept learning. So concept learning in the sense, whatever the data which we are going to be consider for whatever the concept we are going to discuss, that will be covered in the concept learning. And then next, general hypothesis. So what is general hypothesis? Whatever the negative data which we are going to be considered, that will be deals with negative general hypothesis and specific hypothesis. Already we discussed about the specific hypothesis. What is the specific hypothesis? So here we are going to deal with as finder's algorithm, we are going to deal with positive examples, that is specific. And here pi is a symbol which we are going to be represented for specific, like this, and question mark is a symbol for general hypothesis. And version space is the intermediate of general hypothesis and specific hypothesis. Whatever the data which lies between the specific and general, so that will be represented with the help of version space. Okay, version space. And then we can continue the discussion. Specific hypothesis. So specific hypothesis fills in all the important details about the variables given in the general hypothesis. The more specific details into the example given above would be, I want a cheeseburger with a chicken pepperoni filling with a lot of lettuce. So here this will be the specific hypothesis, most specific hypothesis. So here we are going to consider all pi values. So whenever we are going to consider the data which already we discussed in whether the person is going to play the game or not, enjoy the sport or not, so that we are going to consider, and we will discuss about specific hypothesis and general hypothesis. Next, so here if you look at carefully about the steps which are given under candidate elimination algorithms, first we need to load the data set. Whatever the data we are going to be considered, that is the trainee data, so that should be loaded into the system. And then what is the step 2? Step 2 is very clear. So what we have to do in the step 2? So we have to initialize. What we have to do? We have to initialize. What we have to initialize? General hypothesis and specific hypothesis. Both should be initialized. So that is S0 and Z0. So the second step is going to represent with the help of what we are going to do? S0 and Z0. And what is the step 3? For each training example, whatever the training examples we are going to be considered, if it is positive example, attribute value is called hypothesis value, do nothing. Else replace attribute with question mark. If example is negative, then make general hypothesis more specific. So I will tell you in more simple way the algorithm steps. So this is the algorithm which is going to be discussed. The first step is common. What is the first step? Initialization. Initialization. What should be initialized? So we have to initialize S0 and Z0, most specific hypothesis and general hypothesis. And what is the second step? For each, whenever we are going to consider the trainee data, so what we have to consider? Positive data as well, negative data, yes or no? So for that, what we have to do, for each positive example, so what we have to do? We have to move from specific to general. What is the specific? Pi to question mark in simple way. So this is the 2.1, move from specific to general whenever we deal with positive example. Otherwise, suppose for each negative, one more step, for each negative example, what we have to do? Opposite to that. So that is what we have to do, move from general to specific. So that is a question mark to pi. So this is a very simple way representing this candidate elimination algorithm. Here also what we are going to do, if it is positive example, attribute value equal to hypothesis value, whatever the hypothesis which is going to be given, so we have to consider the hypothesis value, and nothing to do with generalization. And if in case of negative value, what we have to do, so we have to generalize the hypothesis, nothing to general to specific, negative data general to specific, positive data specific to general. So these are the two important steps which are going to be followed in our example. So let me take the example. Just a moment, I am going to consider the same example which I am going to consider, right? So this is the, already we people are familiar with this. What is the example? So this is enjoy sport. How many attributes are there? There are 6 attributes. What are the attributes? So let me tell you the number. So sky is one attribute, air temperature, humidity, wind, water, forecast. This is the classification, final, target. So this is the target. What is the target class? Yes and no. So if you look at the example or data, so how many records are there? There are 4 tuples. So T1, T2, T3, T4. And here if you look at carefully, sunny, warm, high, strong, cool, change and S. Rainy, cold, high, strong, warm, change, no. Sunny, warm, high, strong, warm, same, yes. Sunny, warm, normal, strong, warm, same, yes. So total 4 records are there. So let's start the first step. What is the first step? Initialization of specific and general hypothesis. So for that, what I'm going to do, so see there. So what is the first step? Right, I'm going to start with the initialize. The first step is initializing the hypothesis. So that is, I'm going to consider S0. So what is S0? Pi. How many attributes are there? 6. So how many we need to consider? 6. So what about G0? G0 is most generalized. Question mark. Right? I am going with first step. What is the first step? Hypothesis S1. So what is S1? So we need to consider first record. What is the first record? Positive data. So if it is positive data, what we have to do? So general to specific. Is it or not? Positive data is specific to general, right? So I am going to consider the S first. What is sunny? Sunny in the sense I am going to take sunny. And second record is warm. Third one is high. So for my simplicity, I am taking only first character. And for strong, yes, again ST, if you want confusion. And cool, C. And for change, CH. Right? So this is the first S1. And whenever we are going to deal with positive data, what we have to do? Specific to general. That means we need to change the specific. The general lies as it is. What is the general? G1 equals to as it is. So what is as it is? Question mark. That's it. And next I am going with second, S2. What is S2? No, negative example. Whenever we are going to deal with the negative example, what we have to do? So we should not change the specific. Specific should be as it is. S, W, H, ST, C, CH as it is from previous record. And what about we need to do? We need to change the general. So general to specific. So for that we need to deal with for what is the second one? Rainy. Actually what is there? Sunny is there. So what we have to do? We have to change. What we have to change? Sunny and remaining 6. So we need to consider sub data 1 2 3 4 5 6. That's it. And then next what we have to do? Second. What is the second? Cold. Here what is there? Warm. Here it is cold. Here it is warm. So again it is differentiation. So what is the second record? Warm. So we have to continue with the specific only. So general to specific. So what I am doing here, it is different values are there. So I am going to replace with specific. W and remaining same. Next, high. So what is given here? High only. What is given? High only. So there is no difference. Question mark. And next, strong. That is also same. Question mark. Next, warm. Actually what is there? Warm. Here what is there? Cool. So there is a change. What we have to do? General to specific. So G2, so 1 2 3 4, fifth record. So what is the fifth record? And it is warm, but it is given as warm itself. Rainy, cold, high, strong, warm. So in the given record it is cool, now it is going to be warm, right? So what we have to do? We have to make those specific, so that 1 2 3 4, fifth one is right, it is should be cool and question mark, and change same, so as it is 1 2 3 4 5 6, right. So this is about S2, and now I am going with S3. Specific S3 is positive data, so we have to change in the S3 only. So what we have to do? Sunny as it is, then warm as it is, and high as it is. Next, strong as it is. So here it is warm. Initially it was cool. So what we have to do? We have to generalize that. Question mark. And then next, change. And here it is change. Sorry, here it is same, it is change. So question mark. And G3 will be same. So general, there is no difference. Okay. And so in case of general, what we have here, we have cool, and here it is declared as, this is the only change we are going to observe. So here it is cool, and here it is question mark. We generalized it, so we can eliminate this one. So what are the changes in case of G3? We need to consider only S 1 2 3 4 5, and one more record is question mark, warm 1 2 3 4, and this will be eliminated. So remaining all question marks. So that is the change in G3. And coming to S4, so S4 is again positive data. So sunny, warm, normal. Here it is normal, and there it is high. So here we need to consider question mark, and strong as it is, warm already generalized, and G4 is same. G4 is same. So this is about candidate elimination algorithm. So let's look at the program so that it is clear for you.